Hello and welcome to the third instalment with Ms. Pritchard. You're going to be doing the binomial expansion and partial fractions. If I hand you over now. Thank you.
Hello, so welcome to today. We're going to look at binomial expansion and partial fractions. So we're going to start with binomial expansion. So we would have seen this in Unit 1. So it was used in the expansion of x plus a to the power of n, where n was a positive integer. So this would have been available for us in our formula booklet to look at. In Unit 3, we extend the use of the binomial theorem for 1 plus x to the power of n, where n is any rational value, positive or negative. Okay, so for Unit 3, we'll use the following version of the binomial theorem. So we've got a plus b to the power of n. These are in your formula booklet, and we know that this is n choose r, so that's n to the factorial over r factorial n minus r factorial. Or we've got this one, which is the one I'm mainly going to look at today now, is 1 plus x to the power of n, and then 1 plus nx, n minus 1 of 2 factorial x squared, and so on. We'll see how that works now. And then this version of the binomial theorem will work for all values of n, provided the modulus of x is less than 1. Okay, so the modulus is any positive value of x. Okay, let's look at a question. Okay, so give the first 5 terms of the expansion of 1 plus x to the power of minus 1. State the range of values for x which the expansion is valid. Okay, so I'm going to write that out. So 1 plus x to the minus 1 is going to equal. So what I'm going to do is use this formula here. So I'm always going to be referring to this formula. It's not going to be on the slides, but this is what I'm going to refer to. Okay, so if we look, our first value is always going to be a 1. And then we've got plus nx. So n in this situation is going to be, so if we look, n is going to be minus 1. So you've got minus 1 x, which is just that one, plus, so then we've got n, which is going to be minus 1, and then we're going to have n minus 1, which is going to become minus 2, x. So I'm putting this in brackets because whatever is part of x, so if that was 2x, x or whatever, that's all going to have to be squared. Okay, so we've got 1, 2, 3, and that's all going to be to the 2 factorial. That means 2 times 1, which I'll remember what factorial means, plus, and then the third term is going to be minus 1, minus 2, minus 3 now, because we're going to do n minus 2, x to the power of 3, all over 3 factorial. And then our fifth term, so this 1 counts as our first term, so 1, 2, 3, 4. Then we've got minus 1, minus 2, minus 3, minus 4, x to the power of 4, all over 4 factorial. And then the expansion carries on, but we're only concerned with the first 5 terms, so it's just plus and then dot, dot, dot. So tidying all that up, this expansion is going to be 1 minus x. So then we've got minus 1 times minus 2, which is going to give us 2, divided by 2. So we're just going to be left with plus x squared. So then this one, minus 1 times minus 2 is going to be 2, times minus 3 is going to be minus 6. Then we've got 3 factorial. So 3 times 2 times 1 is going to give me 6. So they're all going to cancel. And I'm going to be left with a minus x to the power of 3. So it's going to be minus because we've got 3 minuses here. Okay. And the next one, we've got 1 times 2 times 3 times 4 minus, and then on the bottom it's going to be 1 times 2 times 3 times 4. So once again, they're all going to cancel. And because there's 4 terms this time, it's going to be a positive x. Okay, so that's going to be our expansion for this one. I've lost my pen. So plus dot dot dot. and the expansion is going to be valid. So we take whatever value is here. So for this, it's just going to be x. So the modulus of x is going to be less than 1, which is what this referred to here. So that's going to be our expansion for that one. So not too bad, just fill in the formula with what you've got, and then this is the only tricky part then, is the expansion, what the expansion is valid for. Okay, so we've got a past paper question here then. Expand 1 plus 3x and over the square root of 1 minus 2x and ascending powers of x up to and including the term x squared. State the range of x for which the expansion is valid. Okay, so first of all, I'm going to rewrite this as the 1 plus 3x times, so because that's on the denominator and it's a square root, that's going to be 1 minus 2x to the power of minus a half. Okay, and then we're going to be doing that up to x squared. Right. So what I'm going to do is expand this bit first and not concern myself with this 1 plus 3x. So 1 minus 2x to the minus a half. So my first term is always going to be 1, and then I've got plus. So my n in this example now is going to be a half, and then I've got minus 2x. Okay, and then my next term, I've got minus a half. Minus a half take away 1 is going to give me 3 over 2. And then I've got minus 2x, and all of this needs to be squared. So I always need to include whatever is attached to my x over here. And that's going to be over 2 factorial. And then the expansion carries on, but I don't need to concern myself because I'm only looking up to x squared. Okay, so sorting this bit out, I get 1 plus minus a half times minus 2 is going to give me just a positive x. And then if we sort this bit out here, so minus a half times minus 3 over 2 is going to give me 3 over 4. Yes, it is 3 over 4. And then this minus 2 squared is going to give me 4. So that's going to cancel out that 4. So I've got 3, and then this 2 is going to be left here. So that's going to give me plus 3 over 2, and that's going to be x squared. So then that was squared, which gave me a 4, which cancelled out that 4. And then dot, 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 because I'm done with that. Okay, so the next bit, I need to bring in this 1 plus 3x back. So what I'm going to do is do 1 plus 3x times everything I just did in that expansion. So 1 plus 3x, and then I'm going to do times 1 plus x plus 3 over 2 x squared, and whatever that was. But I don't need to concern myself because I've already got my x squared here. Okay, so if I multiply those 3 all by 1 first, I get 1 plus x plus 3 over 2 x squared. And now I'm going to times everything in this expansion by the plus 3x. So 1 times 3x is going to give me 3x. X times 3x is going to give me 3x squared. Now 3x times 3 over 2x squared is going to give me 9 over 2x cubed. But I don't need to concern myself with that because here and you asked me up to x squared. So I'm going to cancel that, and obviously that carries on. Right, so my expansion is now just 1 plus. So x plus 3x is going to give me 4x. And then 3 over 2 plus 3x squared is going to give me, well, 3 is going to give me 6 over 2, and 3 over 2, so that's going to be 9 over 2 x squared. And that carries on. Okay, so now I've got my expansion is going to be valid for any values. So this time I need to concern myself with the minus 2. So minus 2x less than 1. So if I take the minus 2 over, and it's obviously because of the modulus, it's going to stay positive, x is going to be less than a half. So the modulus of x is going to be less than a half. Okay, so that's that one sorted. Okay, so expansions in the form a plus x to the power of n. So when the expansion is in the form a plus x to the power of n, there needs to be some rewriting of the expression first in order to use the binomial expansion. So remember, we're using the binomial expansion in this form, the 1 plus x to the n. Okay, so find the expansion of 2 plus x to the minus 3 as far as the term x cubed. Right. Okay, so looking at this then. We need to rewrite this in a nice form. So we can rewrite 2 plus x to the minus 3. So what I'm going to do is divide this. So I'm going to factorize out the 2, okay? So if I factorize out the 2, that gives me 2 to the minus 3 times 1 plus x over 2 all to the minus 3. So if I multiply them in there by that, that will take me back to that, okay? So I've taken that 2 out. So that 2, so 2 to the power of minus 3, so 2 cubed is 8, and that's going to be 1 over 8. So that's going to be equal to 1 over 8, 1 plus x over 2 to the power of minus 3. Now we've got a nice expansion we can work with, as we did before, but now all we need to do is say we're going to multiply the whole expansion by 1 over 8 at the end. Okay, so if I go back to my expansion then, so that's going to equal 1 over 8. So we're going to start with 1, always start with 1, plus, and our n this time is going to be minus 3, and then our x is x over 2, plus, and then we've got our minus 3, minus 4, all of the x over 2 is going to be squared, over, and then we're going to have our 2 factorial, and then plus minus 3, minus 4, minus 5, x over 2 all cubed, and that's going to give us our 3 factorial. And then we would carry on, but we don't need to. Okay, so again, keeping in mind our 1 over 8. If we tidy this up, we've got our 1. So minus 3 times x over 2 is going to give us minus 3x over 2. Minus 3 times minus 4 is going to give me a positive 12. Positive 12 divided by, so that 2 is going to come a 4, so that's going to be 3, so that's going to become 3 over 2. I think. So minus 3 times minus 4, that x squared is going to come a 4. So that cancels out with that, and it's going to stay a positive. So we're going to have plus 3 x squared over 2. Yeah, I think I'm right on that one. And then we've got 3 factorial. So we got minus 3 times minus 4 is 12. 12 times 5 is going to give me 60. And then we're going to have 8 here. So we could just type this in our calculator. I don't know why I'm not doing that. So typing that in on our calculator. So 3 times 4 times 5 is 60. And then we're going to divide that, so that 2 there is going to be an 8, so if we divide that by 8, it's 15 over 2, and then we're going to divide it by our 3 factorial. So 3 times 2 times 1, which is going to give us a 6, so that is going to leave us with 5 over 4. So it's going to be a negative because there's 3 negatives here. So negative 5 over 4 x cubed. Okay. 5 by 6, 5 over 4. Yeah. Okay. And so on. So now our last little bit of this now, before we find where the expansion is valid, we multiply out this whole thing by 1 over 8. So we're going to have 1 over 8 minus, so that's going to give us 3 over 16. So 3x over 16, and then that's going to give us plus 3x squared over 16 minus, and then 4 times 8 is going to give me 32, 5 over 32x cubed, and so on. So the expansion is valid when, so this time we always look at the 1 plus x expansion. We're not going to concern ourselves with that one. So we've got x over 2 this time. So where's my pen gone? Pen's decided to disappear. We've got okay. Okay, so sorry about that. We got x over 2 is less than 1, so x must be less than 2. Okay, so that's that one sorted. Okay, using the binomial expansion, this time we some of the tricky questions in the exam will ask us to find the root of a question. Okay, so the binomial theorem can be used to create infinite series of powers of x that, with the correct value of x, can be used to find the approximate values of the root, square root, cube root, or higher of a number. Okay, so expand 1 plus x over 8 to the power of minus half and ascending powers of x up to and including the term x squared. State the range of values for x which expansion is valid. Hence, by writing x equals 1 in the expansion, find the approximate value for root 2 in the form a over b, where a and b are integers whose values are to be found. Okay, so let's get straight into it. Okay, I don't know why this is decided to be funny, right? Okay, so we've got 1 plus x over 8 to the power of minus a half equals 1. So we always start with a 1 plus n is a half, this time minus a half, and then we've got our x over 8 plus, and we need to go to x squared, so we need to concern ourselves with this one, minus a half, minus 3 over 2 because I'm taking away 1, x over 8 all squared, all over 2 factorial. Okay, so, and then let's see, that carries on. So if we tidy that up, that gives me 1 minus a half, so that's going to give me minus x over 16. And then solving all this on a calculator, because 8 to the squared times 2 is not going to be a nice number. That's going to give me plus 3x squared all over 512. Okay, so does it say where the expansion will be valid? State the range is valid. Okay, so the expansion is going to be valid. We're looking at x over 8 this time, so x over 8 is less than 1, so x is going to be less than 8. Okay, so now if we look, it wants us, hence by writing x equals 1 into your expansion. So I'm going to put x equals 1 into the left-hand side, and I'm going to put x equals 1 onto the right-hand side. So putting in x equals 1 here, so 1 plus 1 over 8 to the minus a half, that's going to give me, so 1 is equivalent to 8 over 8, so that's going to give me 9 over 8 to the power of a half. Okay, so when I write that, I write 9 over 8 then, so the minus a half is going to be approximately equal to 1 minus 1 over 16, add 3 over 512. That's me putting in 1 here. We can rearrange this into something nicer. So we're going to have 9 over 8 to the power of minus a half. That is equivalent to, so minus a half, if we divide, so 1 over 9 over 8, if we divide it, it's going to flip. So that's going to become the square root, because of the half, of 8 over 9. So the square root of 9 is going to be a third. And then we've got the square root of 8. And then the square root of 8, if we split up into thirds, so 8 is equal to root 2 times root 4. And the root of 4 is 2, so that one's going to be equal to 2 root 2 over 3. Okay, so now we know that. We can put 2 root 2, sorry it's a mess, but if we just follow along. 2 root 2 over 3 is going to be approximately equal to this. So putting this here, we are going to get 1 minus 1 over 16 plus 3 and 512. I'm going to take that root 2, put it on its own. So if we want root 2, because that's what it asked us for, root 2 is going to be approximately equal to times 3 on that side now and divide by 2. So 3 over 2, 1 minus 1 over 16 plus 3 and 5 over 12. So root 2 is approximately equal to. So if I solve this, add this together, times by 3 over 2, that gives me 1,449 divided by 1,024. And that's my value of A, and that's my value of B, as they are integers. Okay, so that's how I do that one. Okay, so I'm going to quickly move on now to partial fractions. Okay, so from GCSE, we should remember how to simplify expressions, such as this one. So what we would do is factorize it, and then we'd be able to cancel things down. Or we should be able to solve expressions like this. So not solve, sorry, simplify. So we know when we have two fractions, we can easily put them into one fraction by timesing both sides by the top and bottom by the bottom fraction. Okay. But what happens now if we want to go back into this form? Well, that's what we do, is decompose rational fractions into partial fractions. Okay. So an algebraic fraction can be written in a sum of two or more simple fractions called partial fractions. You can split the partial fraction with two linear factors in the denominator into partial fractions. So let's have a look at this example. Split 6x minus 2 over x minus 3 times x plus 1 into partial fractions. So what we're going to do is we're going to write this in the form. Okay, so write this in the form 6x minus 2 all over x minus 3 x plus 1 into the form a over x minus 3 plus b x plus 1. Okay. Right, so what we're going to do is multiply this left-hand side denominator. We're going to take it up and multiply the right-hand side by that left-hand side denominator. When we do that, so if I multiply this term by x minus 3 and x plus 1, those x minus 3s are going to cancel, and that's just going to leave me with 6x minus 2 equals a. So the x minus 3s cancel. So I've got x plus 1 plus b. So then the same occurs on that one. Now the x plus 1's cancel, and I'm just left with x minus 3. So doing this now, I can set x to a value, and that will enable me to work out a and b. So first of all, I'm going to let x equal minus 1. Now I've chosen minus 1 because if I put minus 1 into here, that gives me 0 for this bracket and it eliminates the a, and I'm just left with b, so then I can solve an equation to find b. So we're going to have 6 times minus 1 take away 2 equals, so again now I'm saying minus 1 and 1 is 0, so the a cancels. So I'm going to have it equal to b, and that's minus 1 minus 3. So 6 times minus 1 is minus 6 minus 2, and b is going to be minus 1 take away minus 3, so minus 4b, so that's going to be minus 8 equals minus 4b. So b is going to equal minus 8 divided by minus 4 is going to give me 2. Now I'm going to do the exact same thing again now to try and eliminate b. So to do that, I'm going to do, well, the positive of this. So x equals 3. So I'm going to do 6 times 3 minus 2 is equal to, now I've eliminated b for this one. So I'm just going to sort out my a's. So I've got a and 3 plus 1. So 6 times 3 is going to give me 18 minus 2, a, and then 3 plus 1 is going to be 4. So 18 take away 2 is 16, which equals 4a. So a is going to equal 4. So now I know them both. I can rewrite this with my a and b in. So 6x minus 2 over x minus 3, x plus 1 is going to equal, well, my a was 4 over x minus 3, and my b was 2. X plus 1. Yeah. So that's that. Okay. So what you can do to check that if it's right, you can put another value of x in. So you put another value of x to see if that is going to be equal to that. Okay. Right. So you can also split fractions that are more than 2 linear factors in the denominator. So let's have a look at this one. We've got 6x squared plus 5x minus 2. And then on the bottom, we've got x, x minus 1, and 2x plus 1. Okay. So this one works exactly the same. We've got 6x squared plus 5x minus 2 all over x, x minus 1, 2x plus 1. And that is going to be equal to a, so I take one of these, over x, plus b, x minus 1, plus c, 2x plus 1. Okay, so now I'm going to do exactly the same. I'm going to multiply by the left-hand side's denominator. So that's going to leave me with 6x squared plus 5x minus 2 equals a. So this time now, the x is cancelled, but I'm still going to be left with the other two denominators. So I got x minus 1 and 2x plus 1 plus b. So basically what I'm doing is putting any other factors into next to the letter other than what's on underneath. So I'm going to have x and 2x plus 1 and then plus c, x and x minus 1. Okay, so this one's quite nice. I just choose the 3 again and solve it. So I'm going to let, no, I don't want a. Okay, so let x equal positive 1 to cancel that. So that means the a disappears and the c disappears. So I'm going to have 6, 1 squared is just going to be 1, minus, plus, sorry, 5 minus 2 is going to be equal to, well, that one's going to go because 1 minus 1 is 0, and that one's going to go for that one. So we're just going to get our b. So b times 1 times 2 times 1 plus 1. So 6 and 5 is 11. Take away 2, that's going to give me 9. And then 2 plus 1 is 3 times 1 is 3, so it's going to be 3b. So b is going to be equal to 3. Okay, so have a look at my next one. So if I let x equal 0, so x equals 0, so I'm going to get, well, 6 times 0 squared is 0 times 0, so minus 2 is going to be equal, and the only one I'm going to be left with now is a. It's going to be a, 0 take away 1 times 0 plus 1, because 2 times 0 is 0. So minus 2 is going to be equal to, well, minus 1 times positive 1, so minus a, so a equals 2. And then finally, we're going to let x equal, what's the one we haven't done? So the 2x plus 1. So to make that 2x into a minus 1, we're going to have to multiply it by minus a half. So we're going to have 6 times minus a half all squared plus 5 times minus a half minus 2 is going to equal, we're left with c minus a half times minus a half minus 1. Okay, so sorting that one out, that's going to leave us with, so 6 over 4 minus 5 over 2 minus 2 equals, and then sorting all that out, that will give me, so minus a half minus 1 is minus 3 over 2 times minus a half, so it's going to be positive 3 over 4 c. So multiplying that side out by 4, that's going to give me 6 minus, well, 4 over 2 is 2, 5 times 2 is 10, minus 8 equals 3c. C is going to equal 6 minus 10 is going to give me minus 4, minus 8, so minus 12, so c is going to equal minus 4. Now that's me sorted for this one, so my a, I'm going to have room here, so all I do is put my a now. So a is going to equal 2, b is going to equal 3, and then c is going to equal minus 4, and I would just write that out underneath them. Okay, this is where it starts getting tricky now. So an expression with repeated linear terms such as this can be split into the form. So we've got x plus 1 squared, so I put x plus 1 squared, and then wherever the squared term is, I'm going to have to repeat that again here, and then I'm left with 2x plus 1. So split this into partial fraction form. So it's already written like that here, so we can write that's equal to that up here. Give me a bit of space here. Okay. Right. So first of all, then let x equals minus 1. So I'm going to have, again now same thing, we're going to do that multiplied by that side. If I write out that here, sorry, so 11x squared plus 14x plus 5 equals a. So anything other than them, so that's going to be the 2x plus 1. Anything other than that one, so that's going to be one of them and one of them. And then c is going to be just the x plus 1 squared. Okay, so if we let x equal minus 1, then we're going to have 11 times minus 1 squared plus 14 times minus 1 plus 5 is going to equal, so a, we're only going to be left with a because minus 1 times plus 1 here is going to give me 0, minus 1 plus 1 here is going to give me 0, so they cancel. So 2 times minus 1 plus 1. So if I solve all that, that's going to be 11, because that's a minus 1 squared. 11 minus 14 plus 5 going to equal, so minus 2 times minus 1 is going to be minus 1 plus 1, so that's going to give me a minus a. So that's 2 equals minus a, so a is going to equal minus 2. Okay, and then we're going to be able to eliminate the a as well, because that's just got one term. So again, we're going to put that as minus a half. So let's see if we have enough room there. Let x equals minus half. So putting all that in, so I put it into the left-hand side and I put it into the right-hand side. I'm going to speed it up a little bit now. So solving that side, that's going to give me so yeah, working all that out, we should have minus 11 over 4 minus 7 plus 5 is going to equal c over 4. And solving all that down, eventually we're going to get c is going to be equal to 3. And then if we let x, right, so, sorry, now we know that. We know a is equal to 2 and we know c is equal to 3. I'm going to put them in and we're going to be able to solve for b, okay? So to be able to solve for b, we are going to need to choose a random value of x. So I'm going to say let x equal 2, right? So we're going to do 11 times 2 squared plus 14 times 2 plus 5. I don't need that. It's going to equal, well, I now know a is 2. So 2 times 2 plus 1. I need to find b, but I know I'm going to put the value of x in. And then I know the c was equal to 3. So I'm going to have 3, so plus 3 times 2 plus 1 all squared. Now sorting all that out, eventually I'm going to get okay, so eventually I will get 44 plus 28 plus 5 is equal to minus 10. Yeah, plus 15b plus 27. So that's going to be 77 equals 17, I stuff my b, plus 15b. So if I take that over, 60 equals 15b. So then b is equal to 4. Okay, so now I've solved that. These are the ones that most likely are going to come up. So this is the main one to put focus on. So we solve for a and c. So we put in a value there. And once we know them values, we put them back in, choose a random value to be able to solve then the third one. Okay, so we can put them in and be able to solve. And again, now, like I said earlier, what we can do is put the value into the left-hand side and the right-hand side to see if they match. And it's always worth writing. I haven't got room here now, but it's always worth writing out then. So this is equal to this, and it fill in the A's, B's, and C's. So we had A was equal to 2, B was equal to 4, minus 2, sorry, and C was equal to 3. So we can write that out. Okay, sorry, it was a bit of a rushed one today, just trying to get through everything. I did have some past paper questions. I have sent the PowerPoint, so it should be uploaded with the resources. I can send through some answers to go with that, so some workings to see if they can be uploaded as well. So hope you enjoyed and hope that helped. A lot to get through today. Join us next week for some integration. So that'll be our last one next week with integration. Okay, thank you.